Hello everyone, my name is Kisoloy Roy and you are watching Saj Education. We are in our second episode of Ratio and Proportion in the master class of Quantitative Aptitude for competitive exams. In the last video, we have seen theories and basic concepts of ratio, proportion and variation. In this video, we will look into some example, quick tricks and some approaches that will help you in the examination to solve the problems quickly. So without any further delay, let's go inside my computer. Let's have a look on our practical study plan. We have already covered the theory part of ratio and proportion. Now we are going to see tips and tricks of the same. In this video we will cover few important approaches of solving the problems, and on the next video we will continue this. After that we will start doing some real problems from previous year questions. So without wasting any further time, we'll start the lesson with the motivation of learning quantitative aptitude, and keeping in mind this is not just a subject, this is a life approach. In this video we will see the examples, the quick tricks and properties, rules and concepts of ratio and proportion. Let's begin with the example of ratio and proportion using some practical situations. So let's see the example number 1. The ratio of number of states in India and states in USA is 14:25. Now what does it mean? If we see the facts that total number of states in India is 28. I'm not talking about the union territories but only the states. So number of states in India is 28 and total number of states in USA is 50. So if we see the ratio, so we just have to make the fraction of these two numbers, that is 28 and 50. So the ratio will become 28:50 equals to 28 by 50. If we simplify this, we will get 14 by 25. That means the ratio will become 14:25. So this is the application of ratio. We can simplify and take the comparison of the number of states in USA and India using this ratio. Let's move on to the second example, that is ratio of number of players in cricket team and football team is 1:1. You know, in a cricket team we have 11 players, and again in football team as well we have 11 players. So if we want to see the comparison between the number of players in both the teams, in both the games, we will get the ratio as 11:11. That means 11 by 11. We can cancel out the 11 and we will get the ratio as 1:1. So that means the number of players in a cricket team is equal to the number of players in a football team. There is no difference in the quantity of players in a team. So this is the practical applications of ratio. We can understand in the daily life how ratio works. Let's see some quick tricks of ratios. Suppose there is a ratio of A:B:C, and that is 3:8:5, and A plus C is equals to 22. Then what is the value of B? Now we can solve this by using K as a variable. We want to see the value of A and C. From this relationship we will get A equals to 3K. We can take this. We can see C equals to 5K, and we can put the values in this equation, correct? And later we have to solve this and get the value of K and put that value again to get the value of B. But if you observe the question properly, you will get the number of units we are seeing in the ratio of A and C. If we add them, we will get 3 plus 5 equals to 8. Correct. And if we observe it properly, number of units for B is also 8. So using this concept that the number of units mentioned in the ratio, we can see the number of units for A plus C is same as number of units for B. So we can just conclude that A plus C is equals to B, and the value of A plus C is already mentioned, that is 22. So we can directly say that the value of A plus C is equals to B, and that is the value of B. Now we are not considering K in this approach, right? Because if we consider it, the value of K will be same for A and C. So if we put that value for A plus C equals to 22 equation, we'll get the value of K, and we'll put it again for the B and we'll get the value of B. But as in all the aspect value of K is same, it will get cancelled out for both the sides. So we can directly approach this and get the number of units for the variables given in the ratio, and we can use it and use our concept, and we can solve these questions very quickly. Let's move on to the next example, that is A is to B is to C equals to 2 is to 4 is to 5, and A into B into C equals to 320. Then find out A plus B plus C equals to how much. Now here we have to use K, because if you see, the value of A should be 2K, right? Value of B will be 4K and value of C will be 5K. If we multiply A into B into C, we will get 2K into 4K into 5K, and the result will be 40K cube. Here if we omit that K, we will omit K cube, right? Here in this previous example we can omit K, because for A plus C the value will be 8K and for B the value will be 8K. But here A into B into C we will get 40K cube, but A plus B plus C we have the value of 11K if we add these three values, right? So if we omit that K, we will omit a K square here, correct? So that will differ the result and we will get the result wrong. So if we compare this equation, we will get 40K cube equals to 320. If we solve this, we will get K cube equals to 320 divided by 40, and that will become 8. Now if you solve this, you will get K equals to third root of 8, and that is 2. Now we have already found out, right, A plus B plus C equals to 11K. How? We just added the values. Now we have already got the value of K. If we put this value of K in the A plus B plus C equals to 11K, the value will become 22. So I hope you understood this approach of solving ratio related problems. Let's move on to the different type of questions. Here we have the equation of three variables, that is 3a equals to 2b equals to 4c. Now we have to determine the value of a is to b is to c. Now you can see here 3a will have a value, and that is equals to 2b, and that is equals to 4c. Now we can say that this value is equals to k, So this is a constant term, right? We can assume the value of k and we can try to solve this problem. Now what should be the value we should assume to solve this problem quickly? Now here is the theory that we have to assume the LCM of the numerator as the constant. Here you can see 3 is the coefficient multiplied to a. There is nothing multiplied in the denominator. Here we have 2 as a coefficient and 4 as a coefficient in the numerator. So we will just find out the LCM of these 3 coefficients, and we will get the LCM of 3, 2, 4 as 12. If we just assume the value of this 3a, 2b and 4c is equals to 12, it will be very easy to solve this problem. How? If we just equate it to 12, you can easily see the value of a will become 12 by 3. Value of b will become 12 by 2 and value of c will become 12 by 4. Correct? Now this is also a ratio, correct? And this ratio will also have a k and that will get cancelled out. So we can assume any number here and we can get the result. But if you assume the LCM as the constant term, it will be easy to get the ratio very quickly. And you can just divide this LCM with 3 and you will get 4, 6 and 3 respectively. The ratio will become 4:6:3. Let's move on to the next problem. Here we have 7a by 5 equals to 5b by 2 and 7c by 3. Here also we have to find out the ratio of a is to b is to c. We will use the same approach of LCM of numerators. Here we have denominators as well, but we will not consider for the constant term. We will just focus on 7, 5 and 7, and the constant we will assume that will be the LCM of 7 and 5 and that will be 35. Now it will be very easy to get the result, that is a will be 35 by 7, that is 5 multiplied by 5 and that will become 25. Likewise we will get the value of b and c and the ratio will become 25:14:15. Here are the few examples you can try and I will give you some problems to solve. You can try it yourself and let me know the answers in the comment section. Also you can download this PDF from our Telegram group. Link is in the description. You can put the answers in the group as well, and also you can post the doubts if you have any. Let's see a property of ratios. This is a property of fraction actually, but it will help you in solving so many questions using this property. So we have to learn what is proper fraction and what is improper fraction. For a is to b, if a is lesser than b, then a by b is called proper fraction. For a is to b, we can write it as a by b as a fraction. Now if a is less than b, then a by b is called proper fraction. How? What are the properties of proper fraction? If we add k, which is a positive number, in the numerator and denominator, the ratio will become greater than the previous ratio. Now if we subtract k from numerator and denominator, the new ratio will become less than the previous ratio. You can take an example that 4:5. If we add 1 in numerator and denominator, we will get 5/6, and if you see the values, 4/5 is equals to 0.8, and the value of 5/6 is 0.833 almost. Now you can see the value of the ratio increased after adding a number in numerator and denominator. If we try to subtract 1 from the same ratio, we will get 3/4, and you know the value of 3/4 is 0.75. Here you can see the value decreased. Correct. So if we add a number in the numerator and denominator, the ratio will increase, and if we subtract a number from numerator and denominator, the value of the ratio will decrease. Now this is the same property we can use any ratio related problems, because ratio can be represented as a fraction. So this will be a very useful property to identify the proper and improper fraction. Now let's move on to the improper fraction. For a is to b, that means a by b, if value of b is less and value of a is greater, then it is called an improper fraction. Here the property is, if we add a positive number in the numerator and denominator, the value of the fraction will decrease, and if we subtract a number from numerator and denominator, the value of the fraction will increase. If you see with the example, it will be easier to understand. Let's take an example. Suppose 4/3 is a fraction, and you can see here 4 is greater, so it is an improper fraction. Now if we add 1 in the numerator and denominator, we will get new fraction as 5/4. Now if you see this fraction, the value is 1.33, and the value of 5/4 is 1.25. Here you can see, after adding a number in numerator and denominator, we can see the value of the fraction decreased. You can try to subtract a number from the numerator and denominator and try it yourself. You will get the new ratio, the value of the new fraction increased. Suppose a is to b is 7:6, and the actual value of a decreased by 2, and the actual value of b is also decreased by 2. What is the new ratio of a is to b without knowing the actual values of a and b? If we have 4 options, 7:8, 7:6, 9, 1:1. You can try to solve this using previous lesson we have learned about the improper and proper fraction. I'll solve it for you, but we don't need to solve anything. You can just look at the ratio and you can easily tell the answer. Here we have 7:6. That means 7/6. Correct. Now if we subtract -2 from both, you'll definitely see that the new ratio will be greater because it is an improper fraction. And for improper fraction, if we subtract any number from numerator and denominator, the resultant fraction becomes greater. Correct. Now how we can determine a fraction that is having a greater value? Either the numerator will be higher if the denominator is fixed, otherwise if the numerator is fixed, denominator will be lesser to increase the value of the fraction. Here we have, you can see in the options, we have 1, 2 and 3. In all three options you can see the numerator is 7. So we need to focus on denominator. To increase the value of this fraction, the denominator should decrease. So here we have 5, that is lesser than 6. For others we have 8, 9, and if you consider this one, this is actually 7:7. So 8, 9 and 7, all three are greater than 6. Correct. So 5 will be the answer, as the resultant ratio will be having higher value. So the first option is the answer. Likewise, you can solve this kind of problems very quickly if you practice it properly, and this is a good approach to know the proper and improper fractions. So what have you learned from this lesson today? The properties, rules and tricks for ratio and proportion. We have focused on ratio today. Tomorrow we will see some other tricks for proportion as well. So let's summarize what have we learned from today's lesson. First one is to determine the addition of the variables where we have the ratio of those variables without using the constant term k. Another point is how to determine the multiplication of those variables if we know the ratio using k. We can't omit the k if we want to use the multiplication of the variables for the ratio, because the k term will not get cancelled out, rather it will get multiplied and produce a higher degree of k. Now the next approach is the LCM of numerator approach. That means if we have an equation relating the variables, we can determine the ratio using the LCM of numerator technique. We will not consider the denominator as we have already seen. Finally, we have learned proper and improper fraction techniques to solve the ratio related problems. In the next video, we will see more tricks to solve the ratio and proportion related problems. I hope you have already solved these problems. Please let me know in the comments, or you can join my Telegram channel to get this PDF. If you like this video, hit a thumbs up and let me know your views in the comment section. And if you have any queries, you can DM me. A link is in the description. you can directly send me message in the WhatsApp. You can join our community in Instagram and Facebook to get more details. We will see you in the next video.